Hello everyone. Now we're going to do question number 3 on the test. And question number 3 said, an airplane takes off towards another location 340 meters away in the northern direction. So it's going north. From their current location, the airplane travels at a velocity of 15 meters per second. So here I'm giving you a speed or a velocity. Okay. However, they will have to overcome a wind shear that pushes the airplane at 3 meters per second south. So here we can basically handle these two vectors simply by adding them. Here we know that this is going to be going north because it's in the direction that it's going. This is going to be going south, so it's going to be negative. So this is north and this is south. So this would be positive 15 and this would be a negative 3, giving us a speed of 12 meters per second as a resulting vector. Let's go to question A. Explain how you would add the velocity vectors. And in this question, all I'm asking is, how do you handle something like this? In that case, we have to always remember the rule, the summation rules, that when we do vector analysis, we're going to add all the vectors along the x direction where everything to the right is positive. That means anything in the east direction is going to be positive, and anything in the west direction is going to be negative. We also have a rule that the summation of the vectors along the y direction, where everything goes up, is positive. So that means anything going north is positive, and anything going south is going to be negative. So when I ask, explain how we're going to add the velocity vectors, I wanted you to use this rule. So we sum up the vectors along the y direction. Everything being up is positive, so that means north is going to be positive. So this gives us a positive 15 meters per second, and we're going to add it with a negative 3 meters per second. Now here we have 15, here we have 3, so we're really going to subtract 3 from 15. So when we subtract these two numbers, we basically get 12 meters per second. So we use this rule to add it up. What would be the resulting velocity of the plane? The answer for B would be 12 meters per second. The answer for A would be the explanation of this rule. So this would be A, this is B. Now let's go to C. How long would it take the pilot to reach their destination? Now I give you the distance, you now have the velocity, and it's again the same formula of speed and time. So we use the triangle, and I give you the distance, I give you the speed, we're looking for time. So time is equal to distance divided by speed, which gives us 340 meters, and we got a speed of 12 meters per second, which will give us 28.3 seconds. Not bad, huh? Traveling that distance. And an airplane is not that big of a distance. I also don't think it's very realistic. So now let's go to D. So again, this is C. That's the answer for C. Now we go to D. What would the new speed be if the wind shear was 5 meters per second? So basically we're going to follow the same steps for D, only in this case, rather than the velocity being -3, The wind shear now is -5 meters per second, giving us 10 meters per second. And then using that same formula, time is equal to distance over speed, we get 340 meters divided by 10 meters per second, giving us 34 seconds. And that is the answer to the third question.